Okay, so 3.2 is another look at parabolas. So, like I said, we're going to look for the same features in a parabola in different ways. So we're going to continue with standard form here, and then when we get to factored form in 3.3, and then we'll move towards vertex form once you guys can complete the square, okay? So the official definition for vertex is the vertex gives us the axis of symmetry, the x value of the vertex, and the coordinates of the maximum or minimum value. Yes. When we look at the axis of symmetry, we're looking for like where here is it the same on both sides, okay? That's what they've chosen to do, to call the axis. Another thing that is going to be important is where are the zeros? So where does the parabola cross the x-axis? Or the x-axis, the x-intercept? So we're going to use a bunch of words for this. We are going to call them zeros. We are going to call them solutions. We're going to call them roots. As we move along. So again, once we get into word problems, then these values are going to have meaning. If you are going to take physics, if you're into physics, you'll talk about a lot about motion and how things move. And one of the ways that things move when they are subject to gravity is parabolic motion. So you can mathematically predict how something will fall when it's thrown or tossed or dropped from a height. So that's another type of problem we're going to do. We'll do businessy ones and more physics ones. Okay, so the axis of symmetry again is where the parabola is symmetrical, and an axis sort of implies a line. Sometimes you'll see it drawn as a dotted line, usually, to differentiate it from the x and y and the parabola. And again, you're looking for the x value of the vertex. So the optimal value is another word for maximum or minimum. Optimal, again, once we give these x and y values meaning, like the optimal cost, the optimal profit, the optimal height to throw something, okay? So where is that maximum or minimum? Which is given by the y value of the vertex. Oh, and then I guess the last part, just put that in there. So we already did talk about what the y-intercept is, but remember when you have standard form, this c value, or the number without an x, that is the y-intercept. Or you're given the graph, the parabola, and you can see where it crosses. Okay, so this example, you are not given an equation. All you're given is the parabola. So you just look at the parabola and figure out the values. What is the y-intercept? So it crosses the x-axis at, or the y-axis at -3. So really similar to what you would have done in grade 9. Make sure you write it as an ordered pair. So x is 0 and y is -3. The zeros, you do need to remember that's where we're trying to find where the parabola crosses the x-axis. So here and here. The vertex, again, should be written as an ordered pair, so 2, 1. And then when you write the equation, So again, you want to write it as an equation. You can't just write 2. So you need to write x equals 2. And the reason for that, if you think back way back to when we did grade 9 review, if you had a vertical line, then its equation was x equals whatever, because every single value is x equals 2. Okay? You can also, when you draw it in, then you can see, oh, this parabola is the same on both sides. That's what symmetry is. So it is a line, which means then you should write it as an equation. When you're asked for the optimal value, it's sort of similar to this, where this is, instead of just writing 2, you have to write x equals 2 like it's bad math form. Same thing here. So the optimal value, again, because eventually we're going to give that meaning, you want to do the y value only of the vertex. Right, so let's say eventually x is the number of bracelets sold and p is the profit, then the optimal value or the maximum profit you're going to get is determined by the y value. Okay, so we're going to write y equals. So axis of symmetry is the x value, the optimal value is the y value. And then is it a maximum or minimum? So you can look at whether the parabola opens up or down, and remember that opening up is a minimum, opening down is a maximum. Or if you look at the graph then and you say to yourself, y equals 1 is the highest it goes on the y-axis. What is the highest? That means max. Versus if it was up and then it was here, what's the lowest it is? Oh, lowest, minimum, okay? And really you have a 50-50 shot. Okay, so we will continue for now doing a table of values. Eventually, by the end of this section, after chapter 5, then hopefully you won't need to do a table of values anymore. And you'll see that there are advantages to not doing a table of values, right? That's why we do it. So I tried to make this chart a little bit bigger so that I could show my work, okay? So there's the equation, and I'm going to, everywhere it says x, I'm going to sub in -2. So again, decide for yourself. Can I put this in my calculator all at once? Do I need to show a lot of work? So -2 squared, 4. -3 times -2, +6, minus 10. So y is 0. It's up to you if you want to graph the points as you go or wait till the end. when you have this, then your y-intercept is automatically y equals negative 10, which you can see. We got that, so that's good. And our a value says it should open up, and the rest of it we kind of need. So this question, you can see that it's sort of difficult to find what the vertex is. So here, this point is at the same point, so that means that this is not the minimum or maximum value yet. So what you can do is use the step pattern, okay? So there should be symmetry. So then if this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, what is that? 2, 1, 2. Alright, well, let's just make it. Negative 3. 3, negative 10. So then you would go back up. You could do 4. Negative 6. And then if you do 5, then you can see what the zeros are. Two zeros for this parabola. And you can see, even though we don't have a vertex yet, that it's going to be a minimum. It opens up. So how do we figure out the vertex? So it's unfortunate that this one doesn't have the negative 12, but you can kind of see where it's going to go. So I'm going to use the dotted line again. But let's say I don't want to eyeball, okay? So if a parabola is symmetrical and I have these 2 points here, mathematically, where is this point going to be? Halfway, yes. So if you can get the zeros, then you can add them together and divide by 2, and that will tell you the x value of the vertex. Okay? So if I know what x is, and I have an equation, can I find y? Yeah, we can do the same thing that we did here. That's awareness. So there are advantages to different forms of the equation. In the standard form, you can tell whether it's going to open up or down because the number out front of the x squared, if it's positive or negative. You can find the y-intercept. You cannot easily find the zeros without drawing the graph. Finding the vertex, is this a nice vertex? No, not really, right? So that can also be tricky. So for standard form, we're going to use it for the y-intercept. We can use it for the maximum or minimum. But 3.3, we're going to start talking about factored form of the equation, which is a little bit better for other items, okay? So you're going to see different forms of a parabola because they all have advantages over the others. Standard form we're going to use when we do the quadratic formula, if you've ever heard that before. So some advantages, some disadvantages. Okay. So when you have a maximum and minimum value, then again, we're looking for the y coordinate of the vertex as the maximum or minimum value. So if the parabola opens up, then the vertex is the minimum. I tried to make it like this goes with this and this one goes with this. I don't know if you want to draw arrows, but so the y coordinate of the vertex is the minimum value of the function. If the parabola opens down, then the vertex is a maximum. And again, we're always looking at the y coordinate is the maximum value. So again, it might seem redundant. If a question says, write the vertex, write the axis of symmetry, write the optimal value, write the minimum or maximum value, it's just trying to get you used to all of those terms. Okay, so then we have the zeros as well. Like I said, there you can call them zeros, x-intercepts, roots. Okay, so the x-intercepts of the graph of a function are these zeros, or where it crosses the x-axis. So when the x values when y equals 0. Eventually what we're going to do is solve an equation. Okay, so there are grade 11 teachers who are very particular about this next line. Okay, so the x-intercepts of the function are the roots of the equation. In grade 10, you know, it's pick your battles, I guess. So a function we write like this. An equation we set the y value to 0. So we're going to move towards when is it just looking for a y value? When is it looking for y? When does it want you to set the equation equal to 0? Yes. Yes. But you're actually going to see that it has limited usefulness, but yes. There are 3 different possibilities when you can have 2 zeros. You can have 1 0, and you can have no zeros. And again, this really only matters once we start thinking about what do these values actually mean. Is one of the zeros negative? So then if we're talking about time, can you have negative time? No, that doesn't make sense, right? So, but these cases only become important when we do problems. Okay, so let's look at a more practical example using the benefits of standard form. So if I can't print in color, unfortunately, so this is red because this is red, okay? So you'll get an equation and a parabola tomorrow, so make sure it was hard to squish them, make sure that's obvious to you. And this blue one is this blue one here, okay? So what are the coordinates of the vertex? So I'll use my red here. So the coordinates of the vertex, you want to write what it is, 6 to negative 4. And then again, it's sort of, you can start to see the pattern or the redundancy. What is the equation of the axis of symmetry? So you can either, if you prefer, to straight up look where it is on the graph, on the parabola, or you look at the x value, making sure you write it as an equation, x equals 6. And then I'm just going to skip down for a second. The y tells you, the y value of the vertex tells you whether it's a maximum or minimum. This vertex here is the lowest or the minimum value at y equals negative 4. The step pattern, so it's over 1. Now this graph goes by 2s. That's tricky. So it's like over 1, up 1, because it goes by 2s, over 1, up 1, 3, over 1, up 1, over 1, up, it's like 1, 2, 3, over 1, up, 1, 2, 3, 4, 5. And you could keep going. Over 1, up 1, 2, 3, 4, 5, 6, 7. The next one would be 9. Direction of opening you can see, or you could look at the equation. The x squared value is positive. Same thing with the y-intercept. You can look, or you can look at the equation. And the zeros, for sure, you'll have to look at the graph. Okay, so we have the 0 here and the 0 here. Try very hard to write them as order pairs. If you just wrote 4 and 8, I would still give you marks, okay? But again, your grade 11 teacher might get a little bit pickier. Okay, so same thing. Let's look at the graph. This one is 4 and 8. So you can look at the line or look at the x value. Whichever you prefer. I'm going to skip step pattern for a second. You can see that it opens down. You can see that it crosses at negative 24, or you can look at the value in the equation. Use the graph. It crosses at 2 and 6. It's a maximum this time when y equals 8. Okay. I just want you to watch for a second about the step pattern. And again, once we get really into doing the graphs, we'll talk more about this. But let's look at the step pattern for a second. And again, the y-axis is by 2's, okay? So we start here. If we go over 1, we're going down how many? 2. Over 1, down 3 blocks, but 3 times 2 is 6, yes? Over 1, down 1, 2, 4, 5, which is actually 10. So now it's 2, 6, 10. If you compare it to this, what have I done? Doubled it. So whatever number that is there, that's what's going to happen to the step pattern. Okay, so for now, you can just count and figure it out, but you're going to hopefully by the end of this, like I said, you're going to be like, here's an equation, I can draw the parabola, I don't need a picture, I don't need a table of values. We're going to do this over and over and over again. Because it is down, then we usually write negative. Okay, so again, try these questions. Again, I've been really specific about which ones I want you to do. And then afterwards, after lunch, we'll do 3.3 and 3.4.